Okay, so this is 7-4, and now we're looking at systems of nonlinear equations in two variables. So now our graphs or our equations may not be straight lines, they could be quadratic or square root or really any type of equation. We can still use substitution and the elimination method to solve these. For this particular example here, I think it's set up really well for substitution. If I solve for y here, I get y is equal to 3x minus 9. And then I can plug this in for my y value. So I have x squared equals 2 times 3x minus 9 plus 10. And then it's just a matter of distributing and solving. Getting everything on one side and combining like terms, I'll have x squared minus 6x plus 8 equals 0. Factoring, I have x minus 2 and x minus 4. So I get x is equal to 2 and x is equal to 4. Now we don't get to stop there. We need to find the matching y values. So we need a y value for each of these. And I can actually plug those into this equation and find them. So if I plug in 2 times 3 is 6, minus 9 is negative 3. And plugging in 4 times 3 is 12, minus 9 is 3. But what I need to do now is check these values and make sure that they work in both of these equations. So we're going to check. And if I plug in the coordinate, this is going to be 2, negative 3. And this one is 4, 3. So plugging in 2, negative 3 to the first equation, I have 2 squared equals 2 times negative 3 plus 10. 2 squared is 4, and that's negative 6 plus 10 is 4, so this one works. But it also has to work in the other equation. So 3 times 2 minus negative 3 equals 9. And that's 6 plus 3 is 9. So this one also works out. So this point's good. And now we need to check for 4, 3. And plugging in 4 squared, and 2 times 3 plus 10. 4 squared is 16, and then 6 plus 10, so this one works out. And then here we have 3 times 4 minus 3 equals 9. And that would give us 9 equals 9, so that one works out. So this one also works. They won't both always work. Sometimes one solution will work and the other one won't. Let's look at the next example here. So here we have a linear equation, and then this graph should look familiar way back from chapter 9, and this would be a circle with a center at 2, negative 3, and a radius of 4. So we're going to go ahead and solve here. We have a few options here. What I recommend doing is solving here, and if we add y to both sides, x is equal to y plus 3. And then we can substitute in here. So we can substitute in 4x, and we have y plus 3 minus 2 squared plus y plus 3 squared equals 4. 3 minus 2 is 1. Y plus 1 squared plus y plus 3 squared equals 4. And now I can actually multiply those out. So I'm going to multiply these out, and I'll get y squared plus 2y plus 1 plus y squared plus 6y plus 9 equals 4. Combining like terms, I get 2y squared plus 8y plus 6. And if I'm subtracting the constants over, equals 0. So if I subtracted that 4 over. And I notice that all of these terms are divisible by 2, so y squared plus 4y plus 3 equals 0. Just to make sure, in case you didn't see how I went from here to here, all I did was subtract the 4 over and combine like terms. And then we divided by 2, and now we can factor, and we have y plus 3 and y plus 1 equals 0, so y equals negative 3 and y equals negative 1. And now we need to find the corresponding x values. Okay. Now, when we find those corresponding x values, we have an equation here. So plugging in -3 plus 3 is going to be 0, and then -1 is going to give us 2. So we have the point 0, -3, and we have the point 2, -1. And now we need to check our answers. Okay. So we're going to check and plug those in. So for 0, -3, for the first equation, that's going to be 0 minus -3 equals 3, and that one works. And then plugging into the other equation, let's see, 0 minus 2 squared plus -3 plus 3 squared equals 4. And yep, that works out. So this one is a solution. And checking to -1, we can plug that into the first one. So plugging into the first one, we get 2 minus -1 equals 3, and that one works. Plugging into the other one, we have 2 minus 2 squared plus -1 plus 3 squared equals 4, and that one works as well. So both of these are solutions. I'm going to go ahead and flip the page now to our next example. And looking at number 3, I noticed that both of these graphs here have an x squared and both of them have a y squared. So I'm going to try and use the elimination method here. I'm going to try and cancel out my y's. So I'll multiply the second equation by -1. And multiplying by -1, I have 4x squared plus y squared equals 13. X squared minus y squared equals -10. We have 3x squared equals 3, so x squared equals 1, so x equals plus or minus 1. Okay. Now we have two x values here, and so we need to find the corresponding y values. So I'm going to plug into the second equation. If I have positive or -1 plugged in, squaring them is going to give me 1, so 1 plus y squared equals 10. Subtracting 1, y squared equals 9, so y equals plus or minus 3. Now because we have all of these options here for x equals 1 and x equals -1, we're actually going to end up with 4 coordinates. So for 1, I'll have -3 and +3. And for -1, I'll have -3 and +3. So I need to check all 4 of these points. Now, in order to just save some time here, rather than taking the time to plug all 4 in, I can tell you right now, all 4 of these work, so all 4 of them are solutions. Now looking at this next example, this is our last example in this section. One of these is a quadratic or a parabola, and the other one is going to be a circle. So let's go ahead and go through the process. It looks like it's set up for substitution, but I think I actually am going to use the elimination method. I want to cancel out my x squareds. So if I subtract this to the other side, I have -x squared plus y equals 3. In the bottom equation, I can leave the same. If I add them together, I have y squared plus y equals 12. And bringing everything to one side, I have y squared plus y minus 12 equals 0. So that would be y plus 4 and y minus 3 equals 0. So y equals -4 and y equals 3. And now we need to find the corresponding x values. And when we plug in those corresponding x values, or plug in those y values here, when I plug in y equals -4, let's see. I have -4 equals x squared plus 3. Subtracting 3, I have -7 equals x squared. And that is going to give me no solution because there's no real numbers that can come out of this. So already I know that this is not going to be a solution. But let's try for y equals 3. If I plug in y equals 3, equals x squared plus 3, subtracting 3 from both sides, x squared equals 0, so x equals 0, and that one's good. And we can plug into the other equation just to make sure. If I have y equals 3 and x equals 0, we have 0 plus 3 squared is 9 equals 9, and that one works. And this is our solution, 0, 3. And that is the end of 7-4.